If you're an iOS developer, you've definitely been there. Your app starts out simple, it's fast, it's fun to use, but as you keep adding features, piling on more data, and making things more complex, a little shadow starts to creep in. Your app gets slow. So today, we're putting on our detective hats to investigate and solve the case of the laggy Swift UI app. This is the question that keeps us up at night, right? That perfectly smooth scrolling starts to stutter, buttons feel like they're stuck in molasses, and loading screens just hang there for way too long. It's frustrating for you as the developer, and you know it's a terrible experience for your users. So what is actually going on under the hood? Okay, here's our game plan. We're going to follow this investigation from start to finish. First, we'll look at why good apps go bad performance-wise. Then, we'll meet our primary suspect, the main thread. After that, we'll get our hands on a professional detective's toolkit. We'll crack a live case with a real fix, look at some other common clues, and wrap up by building the right performance mindset. So let's set the scene. Think back to your first few apps. Performance probably wasn't even on your radar. But as you start building bigger, more professional apps, the scale just changes completely, and so do the challenges. See, as your app gets more sophisticated, all these things start to pile up. You're not just dealing with a handful of items anymore. You're fetching huge chunks of data over the network, you're loading images, saving stuff to a database, and you've got multiple views all trying to update at once. Each one of these things is a potential little speed bump, and when you put them all together, they can bring your app to a grinding halt. The official term for these slow points is a performance bottleneck. This is exactly what we're hunting for. It's not some vague feeling of slowness. It's a specific piece of your code that is taking way too long, eating up too much memory, or, and this is the big one, getting in the way of the user interface. All right, let's meet the number one suspect in almost every single case of a frozen or unresponsive app, the main thread. Seriously, understanding this one concept is absolutely crucial for building apps that people love to use. So think of the main thread like this. It's a single, dedicated worker who is responsible for literally everything the user sees and touches. Every tap, every scroll, every cool animation, it all has to go through this one worker. And because there's only one, well, it can only do one thing at a time. And this is where it all goes wrong. If you give that one UI worker a really heavy, time-consuming job, like crunching a huge amount of data or a complex calculation, it gets completely stuck on that task. And while it's busy, it can't respond to taps, it can't update animations, it can't do anything. The entire app just freezes solid until that heavy work is finally done. So what's the solution? Well, thankfully, it's a simple two-step rule that every pro developer lives by. First, any heavy lifting, you send it off to a background thread, away from the UI. And second, once that work is done, you send the result back to the main thread so it can safely update what the user sees. This keeps your UI completely free and responsive the entire time. Now, to find these bottlenecks, we've got to upgrade our tools. Just guessing where the problem is, well, that's not going to fly. We need hard evidence. And that means moving beyond simple print statements and using the professional tools built right into Xcode. Look, we all use print statements. They're great for seeing what a value is, but they can't tell you how long a function took to run or if it's leaking memory. To find those clues, we need Xcode's Pro tools. They're like our magnifying glass and fingerprint kit, showing us CPU spikes, memory usage, and pointing to the exact functions that are slowing us down. And your investigation starts right here, in a place you already know, Xcode's Debug Navigator. Just by keeping an eye on those little CPU and memory graphs while you use your app, you can spot huge clues. See a massive spike in CPU when a new screen appears? That's a lead. See the memory usage just keep climbing and never go down? That's a major red flag. All right, enough theory. Let's see this in action. We're going to examine a classic performance crime. Doing heavy work right where it can cause the most damage. Okay, here's our before scene. We've got this function, heavy computation, running directly inside the view's body. Now, why is this so bad? Because the body of a Swift UI view can get redrawn many, many times. Every single time the state changes, this expensive function runs again, and it runs right on the main thread, blocking absolutely everything. And you can just see the impact in the metrics here. CPU usage is through the roof, UI responsiveness tanks, and well, user happiness goes right down with it. The app feels broken, even though the code is technically working. This is a classic bottleneck. Now for the fix. We move that work out of the body and into a task modifier. This runs when the view first appears. But the real key here is task.detached. This creates a brand new task that runs on a background thread completely separate from the UI. This frees up the main thread to do what it does best, keep the UI snappy and responsive. And with that one little change, the case is solved. The view appears instantly, the UI feels great, the heavy work still happens, but it does so quietly in the background, and the result just pops into place when it's ready. This is how you create a great user experience. So that main thread culprit is a really common one, but it's not the only performance problem you're going to run into. Let's take a look at a few other usual suspects that you should keep an eye out for in your own projects. Here are 3 more classic clues. First, like we saw, any repeated work in the body needs to be moved to a dot task. Second, if you're trying to display a super long list of items in a regular VStack, SwiftUI tries to create all those views at once, which can just destroy performance. The fix? Use a lazy VStack. It's way more efficient because it only creates the views right before they're about to scroll on screen. And finally, stop loading huge, full-resolution images for tiny little thumbnails. It wastes a ton of memory. Resize your images first. It makes a massive difference. Okay, now that we have the tools and the tactics, let's talk about the most important thing, the long-term strategy. Being a performance detective isn't just about one-off fixes. It's about developing a professional mindset. This is the code that every performance-aware developer lives by. You don't start by trying to make everything fast. You start by writing clean, correct code. Then you actually use your app. If you notice a real slowdown, you use your tools to find the actual bottleneck. You fix that specific problem. And the key here is to avoid premature optimization. That's just wasting time trying to fix code that isn't even slow to begin with. This quote just sums it all up perfectly. Your goal isn't to just randomly make everything fast. It's a targeted investigation to find what is actually and measurably slowing you down. It's about being precise, not just guessing. So now the case is in your hands. You have the rules, the tools, and the mindset of a performance detective. So think about your own projects right now. Is there a laggy scroll, a screen that loads too slow, a button that feels delayed? What's the first clue you're going to investigate?